I made a part program using pictogramming. And what the pictogramming is, students put together all your basic geometries as far as diameter grinding, contour grinding, and non-round shapes and forms. From the diameter grind, we have options for a straight diameter grind, a shoulder grind, an angular plunge grind, and the taper grind. You look at your drawings, you look at the features on your drawings, you select the geometry direct from there. So as far as our part print, or our part that we just selected, alright, as I cursor through here, you can see on the information block the information that's in the pictogram. So my wheel selection, first operation, the grinding wheel was set up at 30 degrees. I give a command for the gauge to go in. We're going to monitor and gauge that first part, first diameter being ground. And the cycle I selected was plunge with oscillations. You look at your part drawing and you nominally dimension. If I cursor down, I go from my information block into the edit block. And here's where I fill in a diameter. And it'll tell me as I cursor through here what it needs information for that line. Nominal size in X is my diameter. Nominal size in Z is what position or what shoulder I'm going to dimension to. We have a grind stock allowance, which means the machine rapids to a start position, then it starts the grind cycle. So then from there, we have three possibilities. A, B, and C are positions. That's rough, medium, and fine. And then D, E, and F are how quick we go from A to B, B to C, and then C to finish size. All the cycles have 3 steps in them. So first operation was a plunge with oscillation. I removed the gauge, the diameter is now complete. I then did a shoulder plunge with oscillation, and you would use this if the height of the shoulder on the workpiece is higher than what the height of the grinding wheel is. So we'd have to make an oscillation move on it. And once again, if you see, similarities are, we have a diameter size, we have a Z position size, or our length size. A, B, and C are positions, D, E, and F's are speeds. Next operation is just a straight shoulder plunge where we grind an overall length. I can change finish, I can change size basically with the shoulder plunge. I then swivel the wheel to 40 degrees. The original setup was 30. I'm now going to grind 10-degree taper on the workpiece. So I manually move the B axis to 40 degrees, which is 10 for my parallel setup, and I can plunge on a taper. So I do this 2 times. There's the first operation with plunge on taper. Note the icon. Second operation, plunge on taper. And for this feature, what I did is I just copied and pasted, and I only changed dimensionally 2 features. Other than that, that pictogram or that feature is done. I now swivel the wheel manually 180 degrees for the internal grinding wheel. I let the machine know via this icon that it's ID grinding, so I have a bore approach position. And then I did a multi-plunge and traverse on the bore, meaning the width of the bore was wider than the width of the wheel, so I couldn't do it in a single plunge. I had to do it in a multiple plunge. So plunge, 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 finish with a traverse grind, spark out, dwell. Bore retract means it comes out of the bore, and then end of cycle and complete. Finished.